Hello Tracy, this is Jesus, and this is my video section of the exam. So we are going to be working on those, and I'm going to follow your prompt. So we're going to state a distribution, okay, and state what is being asked and how I know, okay, and then what function I will use. Okay, so let's go ahead and start with question 1, which says that a manufacturing company finds that the mean lifespan of one of its cameras is 3.4 years when the standard deviation of 0.72 years. If the manufacturer sells all cameras with a 2-year replacement warranty, what is the percentage of cameras that will need to be replaced under the warranty? Okay, so in this case, I'm going to use a normal distribution. I assume this is a normal distribution based on what they're telling me. And my mean is equal to 3.4. I know this because that's the mean lifespan once again. And then my standard deviation is 0.72. Now, what I will use in my calculator is the normal CDF function. And then I will use, let's see, they want to know the percentage of batteries that will need to be replaced within the first 2 years of the warranty. Okay, so this is something that I can do. Technically, my lower limit could be -10 to infinity, but I'm going to put 0. I guess this is kind of a tricky one. I would put 0 just because this is like 0 from when it was made until it expired. So that's what I'm going to use, 0. And then my upper limit will be 2. And then my mean is 3.4. And then my standard deviation is 0.72. So now I'm going to go into my calculator and do this equation. Equals. So let's turn on our calculator. We're going to go to the second vars. We're going to find our normal CDF, our lower. Once again, I said 0. This is what I'm going to go by just because it can be negative if you've manufactured it. It only counts from the day it was manufactured. In my head, that's how I see it. Then my upper is the 2 years. My standard deviation is 3.4. Sorry, my mean is 3.4 and my standard deviation is 0.72 years. So I do this, I close my parenthesis, and I get a percentage of 0.0, yeah, a very small number. So I'm going to multiply this times 100 to get a percentage, and I get a percentage of 2.59. So I'm just going to round it to 2.6%. Well, we'll just say 2.59, round it to 3, or 2.6%. I don't see how much you want me to round to, so I'll just do this. 2.6% is my answer. That means that 2.6% of cameras will need to be replaced under the warranty. The remaining will be okay. So it's a very small number that they'll have to replace. This is the percent of cameras that will need to be replaced within warranty. Okay. Now let's go to question number 2. A pharmaceutical company receives large shipments of ibuprofen tablets and uses the following acceptance sampling plan, randomly select and test 23 tablets, then accept the whole batch if there is at most one that doesn't meet the requirement in regard specifications. If a particular shipment of thousands of ibuprofen tablets actually has an 8% rate of defects, what is the probability that his whole shipment will be accepted? Okay, so 2 things. This should be a binomial distribution. How I know this is I have 23. This is the number of trials, or n. I have a rate of success, so it's success or failure, and this should be independent. Ibuprofen, if one goes wrong or doesn't work, the other one doesn't mean that it should be way off. So I have a binomial distribution, and that's how I know. So once again, my binomial distribution, my little n is equal to, I'm just going to put that, n is equal to 23. My probability is my little p, 0.08. Okay, so what they're trying to find out is, let's see, if a particular shipment, okay, so they will only accept if X is less than, at most, less than or equal to 1. Let me see if I can write here. Insert and symbol. We'll give this a little bit to wait. Less than so I can't find it, but it would be this symbol with a little X bar. So we'll just leave it as this. So what we're going to use, this is what we're looking for. We are going to use our Binomial CDF to find this out. We put our mark and let's see. So let's open our calculator on second bars. So we said 23 trials. P is 0.08. And then we want to know our number. And why I use binomial CDF is it can be up to the number. And that number is 1, because they will only accept 1. At most 1. Okay. So binomial CDF, and then it'll be 23, comma 0.08. That's our probability, and then 1 is equal to 0.4408. So out of the 23, if they select an ibuprofen, then sorry, there is less than 50% chance of them getting one that is defective. So what is the inverse? What is the possibility that this will not be defective or that this will be okay? Then we can do the opposite because this is an inverse. There is a binom CDF 23.08 1 1 minus binom 0.08 and then we go to 0. What I'm trying to say, sorry, is 1 minus 0.4408. I was doing my math wrong. 1 minus 0.4408. 0.5592. 0.5592. Now this is the probability that stuck here for a moment, but I can think this through. Yeah, we can go back to here once again. So we found that that is the probability of it being defective. Then there is a, let's go and find that number again. There it is. 0.55592% chance that this will be accepted. Because that's a reminder that the rest will be the opposite, the inverse, that they will work. Ibuprofen will not be defective. Okay. And shipment will be accepted. Okay. A manufacturing company finds that the mean lifespan of one of its cameras is 3.4 years with a standard deviation of 0.72. How long does the longest lasting 10% of cameras last? Okay, so we're presented once again with a normal distribution, mean lifespan. So we're gonna use normal distribution. And then we are going to see our mean is equal to 3.4. Standard deviation is 0.72. So now we're looking for a percentile, and we're actually looking at the top 90, the longest lasting 10%. So we're going to use the inverse norm because we're looking for a percentile. And that'll give us the in years, the top 10 longer lasting based on this data. So inv norm, and let's open our calculator and find that equation. So on second bar inv norm area, we want 0.9 because that'll be our top 10. We'll find up to that. And then our mean is 3.4, and then our standard deviation is 0.72. Okay, so 0.9, 3.4, 0.72 is equal to 4. We'll just round it to 32 years. So the top 10% of cameras last about 4.32 years. I don't know. I guess they don't make things like they used to. I hope my camera, depending on how much it costs, can last longer. Okay, so Alicia has loaded a 6-sided die that rolls 6, another number. Probability distribution table is given below. What is the expected value mean of die rolls? Okay, so we're looking for a mean. This is not quite a standard normal distribution because our number 6 has a higher probability than the rest. So this would be a discrete probability distribution. How I know that is, let's see, 0.5 and then 0.1, 0.1, 0.1, yeah, that adds up to 1. It adds up to 1. And how we're gonna do this? Well, this is simple. We're just gonna go to our calculator, and there's no, I guess, what I'm gonna use is the lists in 1-bar stats. So let's go to our calculator. Second vars. Inf norm, let's see, sorry. We're gonna go to the stats section. We're gonna create a list. Oh, I might have gotten ahead of myself. So we're just gonna do that again. So we're going to create a list. And L1 will be the 1, 2, 3, 4, 5, 6. And then on our frequency list, 0.1, 0.1, 0.1, 0.1. Oh, I did -1. Stat. Edit list. 0.1, 0.1, 0.1, 0.1, 0.1, 0.5. Okay, that looks about right. So now we're gonna go to the edit portion and then, sorry, stat, the calc portion. We have that in the right order. Okay, so we found our mean. Our mean, or x bar, It's equal to 4.5. And let's just make sure that our table is correct. 0.1, 0.2, 0.1, 0.1. Okay. Yes. So that is our answer and our final solutions for the video. Okay, thank you.